Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. The spaceship left the solar system in 2012.
Voyager drifted through the darkness like a lantern abandoned in an infinite sea, its weakened radio pulse still faithfully stretching back toward a pale blue dot it had not seen for nearly half a century. Engineers at JPL had grown accustomed to the silence between transmissions, but the newest data packet made even the most stoic scientists lean forward in their chairs. The packet contained something strange, an abrupt spike in thermal readings. Not minor fluctuations, not noise, but a surge so intense it seemed impossible. Something near Voyager was hot, extremely hot, far hotter than anything the spacecraft should encounter at the edge of the heliosphere. When the data was graphed across the screen in the monitoring room, a thin red wall rose from the baseline like a blade. The math was run twice, then a third time, then independently by two separate teams. There was no mistake. The temperature reading was approaching 50,000 degrees. No one spoke at first. The Heliopause was supposed to be cold, quiet, a gentle draping of interstellar particles brushing against the solar wind. Nothing about it should have produced that kind of heat, and certainly not a physical wall. The first explanation offered was a software glitch. Voyager was old, circuits degrade, sensors drift, but the raw data stream showed redundancy checks and signal integrity in perfect condition. The thermal shift had been recorded simultaneously by two separate instruments, meaning it had to be real. As more packets arrived, the picture sharpened. This wasn't a spike. It was a boundary. A boundary Voyager appeared to be approaching steadily, like a blind traveler extending its hand towards something immense. Scientists began calling it informally the wall. Some leaned into the term jokingly. Others whispered it with quiet dread, because nothing in current astrophysics predicted a 50,000-degree structure at the edge of the solar system. Within 24 hours, the discovery moved from a curious anomaly to a controlled internal investigation. NASA requested encrypted communications between departments. ESA asked to review the telemetry. JPL restricted data access to specific personnel. The stakes had risen quickly and everyone could feel it. The wall wasn't uniform. Its intensity pulsed in a strange rhythm, appearing to strengthen and weaken every few minutes. Plasma doesn't behave like that. Dust clouds don't behave like that. Even bow shocks around stars aren't so sharply defined. Some astrophysicists suggested it might be a shock front created by the solar system moving through a dense patch of interstellar medium. But the shape, sharp, steep, almost abrupt, made little sense. A natural boundary should have been smeared across billions of miles. This one, according to Voyager's readings, was only a few hundred miles thick. The team ran simulations of plasma compression under extreme magnetic tension. The results came close, but even then, the predicted temperatures were far lower. Something was amplifying the energy. The first whispers of an artificial explanation began to circulate, quietly, off record, among scientists who normally scoffed at anything that smelled of speculation. Voyager's magnetometer next picked up oscillations, beautiful, rhythmic, patterned, not noise, not random, a sequence, repeating every 7 minutes, like a heartbeat. It was enough for some on the team to sit back in stunned disbelief. The Voyager missions had delivered wonder before, the volcanoes of Io, the storms of Jupiter, the methane seas of Titan, but nothing like this, nothing that felt intentional. When the readings leaked to a freelance science writer, the public learned of the thermal anomaly. Panic followed quickly, social feeds exploding with claims of alien barriers, dimensional gates, hidden cosmic structures, and interstellar quarantines. NASA held a press conference trying to calm the storm. They framed it as a natural plasma compression layer, a harmless effect of the interaction between solar and interstellar winds. But the scientists behind the scenes felt uneasy repeating the talking points. Voyager continued forward. Every hour brought it closer to the wall. Then another strange thing happened. The spacecraft's instruments began experiencing micro-resets. Systems would flicker off for fractions of a second, as if brushed by a field of intense electromagnetic interference. But there was nothing around Voyager capable of generating enough energy to cause it. The resets aligned with the pulsing oscillations from the wall. A cause and effect link became undeniable. Something ahead was projecting energy in a regulated rhythm. One researcher proposed a radical theory. The wall might be an ancient, naturally occurring plasma structure left over from a violent cosmic event, a supernova shockwave, or the remains of a magnetized interstellar filament. Over millions of years, such a structure could have become layered and compressed. But the predictability of the oscillations challenged that idea. Nothing ancient behaves with such clarity. A small AI team fed the oscillation patterns into an algorithm designed to detect non-random sequences. The output was immediate. 98.5% probability of structured origin. Not intelligent necessarily, but structured. The line between the two became uncomfortably thin. Comparisons were made to heliospheric models dating back to the 1980s. To their astonishment, researchers discovered similar spikes, tiny, overlooked, barely noticeable, in some of the earliest Voyager transmissions. Over the decades, they had grown stronger, more coherent. It was as if the wall had been forming or strengthening long before anyone realized. Night after night, the monitoring room grew more crowded. Specialists from Johns Hopkins, MIT, Caltech, and several international agencies joined in. Every person on the project sensed that Voyager was revealing something unprecedented, something perhaps not meant to be found. The next data burst changed everything. Voyager registered a sudden drop in temperature, but only on one side of the wall. On the other side, beyond the boundary, thermal readings plummeted to near absolute zero, a contrast of 50,000 degrees across a razor-thin distance. It should have been impossible. The wall wasn't just energetic, it was a divider, a literal thermal border separating two drastically different environments. This raised a terrifying implication. The solar system might be encapsulated within a bubble. One side hot, one side unimaginably cold. A cosmic enclosure. But why? And who or what would construct such a thing? Physicists hesitated to frame the question aloud, yet the implications seeped into every discussion. Could the boundary be a natural consequence of the sun's magnetic field interacting with a denser-than-expected interstellar medium? Or could it be something else, a barrier formed by phenomena beyond current human understanding? As Voyager approached the boundary by another few million miles, energy surges intensified. Its instruments recorded a resonance similar to frequencies found in ancient geomagnetic anomalies on Earth. The match was faint, but real. No one knew what to make of that. The wall began to thicken, according to fresh data. The boundary expanded outward, then contracted as if breathing. It reacted not randomly but responsively, adjusting with surprising precision each time Voyager edged closer. It was the first moment when some scientists privately admitted they felt watched. By the time the spacecraft reached the threshold of the wall, data packets were arriving garbled, bits scrambled, portions missing. Engineers initially blamed the Deep Space Network, but then they noticed something chilling. The errors only appeared in data related to the boundary. Everything else transmitted perfectly. The wall was interfering selectively. Then, in the midst of corrupted data, Voyager sent one clear, pristine burst. A full packet, untouched, as if allowed. It contained the strongest oscillation readings yet. The signal displayed a structure so clean and harmonic that one researcher's voice cracked as she explained it. The pattern was too precise, too controlled. It resembled resonance signatures generated in laboratories experimenting with controlled plasma confinement. Technology tens of thousands of times weaker and smaller, but conceptually similar. The idea that the wall might be a cosmic-scale confinement structure could no longer be dismissed outright. As Voyager crossed the first edge of the boundary, its cameras, long considered useless, recorded light distortion. Not imagery exactly, but warping. Like a lens bending around something invisible, something dense. Voices rose in the monitoring room. Some people cheered, others stared silently. A few stepped back away from the screens without knowing why. The data kept flowing. Pressure readings spiked. Radiation counts flipped into strange harmonic cycles. Magnetic sensors registered directional fields shifting like the interior of a vortex. Voyager had entered the boundary wall. For 14 minutes, the spacecraft transmitted the most extraordinary data scientists had ever seen. Fields oscillated in symmetrical patterns. Temperature gradients formed spirals. Space itself seemed textured, layered, rippling. Then the wall changed. It parted, not dramatically, not explosively, just a subtle opening visible only through shifts in radiation density. A soft window forming directly in Voyager's path. And Voyager drifted through. Silence followed. 8 seconds, then 16, then 24. No one moved. Then a final burst arrived. Short, compressed, containing one last signature. It was unlike any previous reading, an oscillation pattern asymmetric, rising sharply at the end as though cut off mid-transmission. The team replayed it dozens of times. Some said it resembled a greeting, others said it sounded like a warning. Then the signal vanished. Voyager had crossed the boundary entirely. No new packets came. Hours passed, then a full day, then a week. The deep space network scanned relentlessly but heard only static. The wall stabilized behind the spacecraft, its thermal readings settling into a steady pattern as if nothing had disturbed it. Scientists tried to interpret the final signal. They debated every data point, every possible meaning, but no consensus was ever reached. The only certainty was that Voyager had encountered something vast, structured, and impossibly hot, something that marked a threshold between the solar system and whatever lay beyond. And now Voyager was on the other side, drifting into a region colder than any known space, carrying secrets that no one on Earth could yet understand. Humanity's first visitor to interstellar space had vanished into silence. But before that silence, it left one final message, one that still had experts awake at night, replaying it, analyzing it, wondering, was the wall simply a relic of cosmic physics, or was it placed deliberately around us? And if so, who built it, and what waits beyond? The weeks following Voyager's passage through the wall were unlike anything the space science community had ever experienced. Teams stayed glued to screens, reanalyzing every data packet ever sent from the spacecraft, searching for subtle patterns they might have missed before. Every anomaly now seemed potentially significant. Old Voyager recordings from decades ago, previously considered mundane, were now scrutinized with new eyes. Tiny fluctuations, faint oscillations buried in static, suddenly felt like breadcrumbs left for those who knew how to read them. Private discussions turned to whispered theories. Some researchers speculated that the wall might be a naturally occurring cosmic lens, a structure created by ancient, massive interstellar events, shaping energy in ways we had yet to comprehend. Others weren't so sure it was natural at all. In conference rooms across the globe, whiteboards filled with equations, sketches of plasma fields, and hypothetical energy flows. Attempts to simulate the wall on supercomputers ran into physical limits. The math could describe it, but the why remained elusive. A breakthrough came when one team decided to model the oscillation sequences using fractal mathematics. The resulting patterns were eerily complex, yet undeniably ordered, hinting at some underlying structure that might have existed for eons. Even the media began to take notice. Headlines oscillated between awe and fear. Voyager discovers cosmic wall, and is the solar system trapped? Public fascination surged, and amateur astronomers started monitoring deep space signals, hoping to catch a glimpse of the phenomenon themselves. Back at JPL, engineers debated the possibility that Voyager might have been the first human-made object to trigger a reaction from the wall. Could the spacecraft itself have somehow influenced the structure, prompting it to pulse more strongly? Scientists began reinterpreting Voyager's previous data as a kind of dialogue, a conversation they hadn't realized was occurring. Signals once ignored now appeared to respond subtly to the spacecraft's own transmissions. A small group proposed sending a new probe along Voyager's trajectory, equipped with modern instruments capable of withstanding extreme temperatures. The idea was met with both enthusiasm and skepticism. How do you launch a spacecraft to investigate something you don't understand? Meanwhile, the final signal from Voyager became the focus of intense study. Patterns within it suggested modulation beyond natural processes, a rhythm almost like a message encoded in energy rather than matter. Universities and research institutions formed task forces to decode the signal. Linguists, mathematicians, physicists, and computer scientists collaborated, hoping to interpret it as either a natural cosmic pattern or an intentionally structured sequence. Some researchers suggested comparing the data to cosmic microwave background radiation patterns, searching for commonalities. Others looked for mathematical constants, sequences like pi or e embedded within the oscillations. A few months in, the team noticed something remarkable. The structure of the signal matched resonance patterns of magnetic fields found on Earth in ancient geological strata. Could this imply a connection between the wall and Earth itself? The idea was radical, even heretical to some. It suggested a cosmic design influencing planetary formation, or at least a shared resonance between human homeworld and the boundary beyond. JPL organized a private symposium to explore these connections, inviting experts in plasma physics, cosmology, and even archaeoastronomy. The discussion veered into speculative territory, considering whether ancient myths might have been inspired by distant cosmic events. One physicist hypothesized that the wall might act as a natural filter, separating regions of space with vastly different energy states. Voyager's crossing could have been the first observation of such a filter in action. Computational models began to simulate how energy waves might interact with a 50,000-degree barrier. simulations revealed that even a small spacecraft could produce detectable perturbations, aligning with what Voyager had transmitted. Meanwhile, astronomers tracked nearby stars for signs of similar walls. No others were found. This seemed to suggest a unique phenomenon, localized to the edge of our solar system, intensifying the mystery. Speculation grew that the wall might be a defensive mechanism of sorts, a cosmic boundary protecting the solar system from unknown interstellar energies. But that notion raised more questions than answers. Who or what could have established it? International cooperation intensified. ESA, JAXA, Roscosmos, and CNSA offered to share data, launching a rare period of transparency in an era of fragmented space exploration. Collectively, they worked to create a comprehensive map of Voyager's path and the surrounding space environment. Deep learning algorithms were trained to predict fluctuations in the wall's thermal and electromagnetic fields. The model suggested the wall was dynamic, capable of responding to intrusions or disturbances, though the mechanism remained unexplained. Public interest exploded when visualizations were released. Heat maps and simulations depicted the wall as a shimmering, almost liquid barrier, wrapping the solar system in a protective shell. Some called it beautiful, others terrifying. The AI team also began analyzing the rhythmic pulses for hidden patterns, akin to musical scores. Curiously, the sequences bore structural similarity to ancient harmonic principles, like those found in classical composition theory. Could the universe itself be inherently musical, structured in ways that humans could intuitively understand through mathematics and sound? This idea captivated a new generation of astrophysicists. Months passed and Voyager remained silent. Yet every day brought small breakthroughs, previously ignored anomalies, tiny variations in the wall's pulse, and correlations with cosmic rays streaming from other parts of the galaxy. The more the team studied, the more the wall seemed like a living entity, a system interacting with its environment, responding to the spacecraft as if aware of its presence. One theorist suggested the wall might predate the solar system, a relic of a previous galactic event, maintained by forces we cannot yet measure or perceive. Others leaned toward an artificial hypothesis, proposing that advanced civilizations could have engineered such a structure, not as a trap, but as a containment or observational system. The debate became philosophical as well as scientific. Some argued that humanity's encounter with the wall challenged the fundamental assumption that space is empty and inert. The simulations suggested that crossing the wall might expose any object to extreme energy states, potentially altering its physical or quantum properties. Voyager, though sturdy, had been a passive participant in this experiment. JPL scientists began considering future missions designed specifically to probe boundaries like the wall, with instruments capable of measuring exotic particle interactions and extreme temperatures. The discovery of structured resonance within the wall inspired experiments on Earth. Labs replicated miniature plasma boundaries, observing how oscillations could influence energy distribution within confined space. Some theorists proposed that the wall functioned as a cosmic resonance chamber, amplifying certain frequencies while damping others. Could it have a purpose tied to interstellar communication or energy balancing? The public fascination only deepened with each new theory. Documentaries, podcasts, and digital media explored the wall, portraying it as both a marvel and a warning of the universe's mysteries. As scientists worked, philosophical questions emerged. Had humanity accidentally stumbled upon a cosmic system that existed beyond comprehension, one that could fundamentally alter the understanding of reality? Even the Voyager team felt small. They had sent the spacecraft into space with modest goals, to study planets, interstellar medium, and the edge of the sun's influence. Now their mission had revealed something far grander. The wall's final pulses were recorded with unprecedented precision before Voyager disappeared into silence. These readings formed the cornerstone for years of subsequent study, becoming reference points for all deep space research. Every subsequent probe into interstellar space would be judged against Voyager's encounter, the first proof that something beyond the heliosphere was alive with structured energy. Eventually, theorists suggested that the wall's energy patterns could be harnessed to study fundamental physics in ways impossible within the solar system. Exotic particle interactions, gravitational anomalies, and quantum states could all be observed at scales unreachable on Earth. Space agencies began planning the next generation of interstellar probes. These would carry far more sophisticated instruments than Voyager, capable of surviving the extreme heat and energy fields of the wall, and sending data back in real time. The silent hum of possibility filled every conference room, every lab. Humanity had glimpsed the threshold of interstellar space and discovered it was far more complex than anyone had imagined. For the first time, the universe felt intimate yet incomprehensible. A place of order and chaos entwined, where a spacecraft could inadvertently encounter a structure of unimaginable heat and intelligence. Voyager had crossed the wall and revealed that boundaries in space were more than physical. They were energetic, perhaps even conscious in ways we could not yet define. The final transmissions became a touchstone for science fiction and reality alike. They inspired new questions. What other walls existed? Could there be corridors between stars shaped by similar energy phenomena? Researchers speculated that the wall might even interact with other cosmic structures, forming a network of energy boundaries across the galaxy. Voyager's crossing had revealed only the tip of a potentially vast interstellar web. Back on Earth, the mission team held a private memorial for Voyager, acknowledging its service and the incredible data it had transmitted. They realized that no probe before or since had ventured this far, nor carried humanity's curiosity into unknown territory with such resilience. Voyager's final legacy became not just the discovery of a hot boundary, but the realization that space itself had hidden layers, energies, and perhaps even intentional structures that could be studied only by venturing into the unknown. The boundary, the wall, remained a cosmic enigma, hot, pulsing, structured, and infinitely complex. Its secrets continued to challenge physicists, mathematicians, and philosophers alike. Even decades after its encounter, Voyager's crossing remained the benchmark for human curiosity and ingenuity, a testament to the courage of exploration and a reminder that the universe still holds mysteries beyond imagining. Every night, when scientists gazed into the vastness of space, they imagined Voyager drifting past the wall, carrying humanity's first intimate glimpse of a universe alive with patterns, heat, and unimaginable energy. And though the spacecraft was silent, the questions it raised echoed louder than ever. What other boundaries wait for discovery? What lies beyond them? And could humanity ever truly comprehend the forces that guard the edges of its solar home? The universe, it seemed, had shown its first grand design, and Voyager had been its first witness.